Okay? So, I want to start out with kind of how not to make some of the same mistakes that I've made teaching programming. So hoping you won't have to get into that. So kind of a quick where we're going. I'll start out with who are you anyway, and then kind of the first attempt that I had of teaching in like a classroom setting, and then kind of a past two of that was for a Take Your Children to Work day, and then kind of a Making a 102 class to follow on, and then kind of some questions. So I work for Qualcomm. My team tries to squeeze every bit of performance out of Snapdragon chips. So for anybody here that is from NC State or just curious, I have some of the cards that the intern people made me promise to bring about positions in Raleigh. So for everybody that's thinking that cool stuff only happens in California or in Texas, that's not true. The actual CPU for all the Snapdragon chips is designed here in Raleigh. I love teaching, especially the look somebody gets when they realize they can do something they thought was impossible. There's just something that's fun and exciting about watching that look when they realize they can do it. And I sometimes get just a little carried away. So enough about me, let's talk about the cool stuff. So in 2011, I decided I would offer a class on Introduction to Microcontrollers as part of a homeschool co-op. So I started looking at materials, and I couldn't find anything I liked, so I did what any reasonable person would do. I wrote my own. And I found out, so I did this, my wife made the cake. I may have gone a little overboard with Arduinos. You know, when you get a birthday cake that's the Arduino and a breadboard. They were really quite bummed because the licorice wasn't long enough to connect all the wires as they were trying to do. And I found out it was cheaper to publish at Amazon than it was to print at Kinko's. So anyway, you can download the book for free at introtoarduino.com, and I can send out a link to it. So if you want to go get the PDF, it's free.
But it's cheaper to buy it at Amazon than to go to Kinko's and print out and you download.
Yep.
Right.
But if you want to look at it as a PDF on your tablet or on the screen, it's free. The class was 90 minutes long and met every other week. We spent 15 minutes talking about last week, then 45 minutes on new material, and then 30 minutes with hands-on wiring. Class met 7 times. It was $100 for the Clarkson book. I was blown away I could do this for $100 because I was remembering when I started how much it cost for this development kit. So we limited the class to 12 students. It filled up very quickly. And this was kind of the syllabus. The week 1 was set up and we made an LED blink. Week 2, we made patterns of lights going on, so we used that to teach if and else and for. Then week 3, we did push buttons, we had potentiometers and sound. Week 4, we had a serial monitor for doing debugging, temperature sensor, and LCD text. Week 5, we did LCD graphics, and we just gave the kids a ton of different sensors. We did Hall effect sensors. We did, I guess temperature sensor was already on there. We did the ultrasonic sensor. We did all kinds of things. So then we did week 6, which for servos, we had the kids build a rubber band gun. So they had a joystick. They had 2 potentiometers that came in. When you pushed it down, it was a push button, and it made 2 servos turn that were on a little bracket so that they could aim and then fire with the 3rd servo, the rubber band. So then we talked about the kids making a project. Then they had a break, and we said, okay, week 7, use anything you've learned so far in the class and bring in a project to show off. Sounds great, right? What could possibly go wrong with this great, wonderful plan? Well, I had to help every family that didn't have an engineer at home get the Arduino software set up. So I learned about all the different remote view solutions to try to help them get drivers set up and walking them through and doing regedits. Again, this was in 2011 when the Arduino stuff was even less mature than it is today. Introducing if statements through math was difficult. Students got it when we got to push buttons, but they didn't really get it when we talked about using if statements for math. Having the class meet every other week was too long in between classes. I had thought they would use the time to work on their project, but they really worked on it all the day before the class again. And it didn't matter. If they had been 1 week apart, that would have been much better. Listening me talk for 45 minutes was difficult for even the best students. And we were doing this in the evenings. They already had a full day. Having the students do all the programming at home was a bad plan. Errors tended to go on for a while. And I should have limited what programming features I taught. I kind of felt like all of the programming features are important. You need to know all of them. Well, you don't need to know all of them at first. So I taught arrays the second week. That was not a good idea. Yes, the project we did that graphed the temperature and scrolled the screen to show a temperature logging over time, that was really cool, but none of the kids actually understood how it was working. And I didn't need to show every part of the language. I really didn't need to talk about the ternary operator. I really didn't need to talk about how to combine logical operations with double ands and double ors and then bitwise operations. All that stuff was unnecessary. But despite all those problems, some things went really well. Every student learned how to program a microcontroller. And the final projects blew me and the parents away. A few of the examples. One of the girls in the class made a temperature sensor with an RGB LED that she wrapped in like some saran wrap. So if it was under the water and it was too hot, the light would be red. If it was too cold, it would be blue. And if it was a safe temperature, it would be green. I didn't want to tell them you could buy this at Home Depot, but they had recreated something. Somebody made a driving game using joystick and a little graphics LCD. Somebody made a jukebox that played different Christmas carols with just the beeping of a piezo buzzer. I'm glad that one wasn't in my home. Somebody made an alarm that went off when their sneaky little brother opened the door. So they used the reed sensor so that the magnet leaving it would be an opening and it would beep at him. Somebody used a joystick to send commands to their laptop. And then I learned a lot about what was easy to learn when you had no background and what was really difficult. So this book has now sold 1,172 copies. So I'm only 23,828 copies away from being a best-selling author. The PDF, the free copy of the book, has been used in teaching classes by many others. And I get all kinds of really cool feedback from people that are using it to teach classes. So I had talked about this at work. And my work has an annual Take Our Children to Work Day. I made the mistake of complaining that what was being shown to the children wasn't even close to what we do. So I kind of got the put up or shut up ultimatum. I was given a budget of $10 per student. You should never give an optimization problem to an engineer. So at that point, we made this little board. So we found these programmers from China for $3.27 a piece, and that's like in quantity 10. And then we made these little boards, and these are from OSH Park the programmers were $2.35. We made the little boards for $3.27 a piece. So for $5.62, we were giving kids entire programming environments. The little board had on it is very simple. It has an AT-Tiny 84 on it. It's got 4 LEDs, and it's got a push button. So, really simple. We borrowed old IT laptops, and we had to put a standard image on each one, and we had them disable the Wi-Fi in the BIOS. That was just to try to not have any problems. It turns out that having the laptops with standard images on them is a lifesaver, because now every single one of them is set up exactly the same. We had students in pair of 2 students per laptop. We had a simple board with push button and 4 LEDs, and we have about 2 hours and 45 minutes. We have about 2 hours before lunch, and then we have about 45 minutes afterwards. So let me show you just the first few challenges. And the way this worked is I would talk for 5 minutes, then they would have a challenge for 10 minutes. Then I would talk for 5 minutes, they would have a challenge for 10 minutes. So I'm going to show you the first few challenges. And if you want the full slideshow, let me know. All this stuff is available. So we'd start out with this as the children came in. kind of the Wizarding 101, and we'd start with, this is the plan for today. You are going to write programs, and you're going to make things happen. And we'd go with the Arthur C. Clarke quote, any sufficiently advanced technology is indistinguishable from magic. So we'd tell them, you're going to do magic today. We'd go over a few rules. It turns out I have not had any problems in the classes. I've also had a lot of volunteers helping, which has been huge, but kind of going over the rules. So I tell them, when you hear me clap, so I would just clap like this, stop talking and look up. Don't run other programs on the computer, although we were smart. On the image, we removed anything that looked like a game from where it was easy to find. And take turns typing. When we got to the last one about have fun, we would need to tell the middle schoolers, you're going to find yourself getting excited as you see lights blink. And you're going to stop yourself thinking, wait a minute, why am I excited about making a light blink? And I would tell them, go ahead and be excited about this. Because just like right now it's a light blinking, it could just as easily be a motor turning. It could just as easily be dispensing medicine to somebody in an IV. What you are doing is you are making something happen. You are creating that never existed before, and it's as close as creating from nothing as us humans can get. So yes, it's exciting, and it's okay to be excited about it. So we would start out, and we'd tell them, plug in the USB programmer. So they would take this, and then plug it in, and the default program we have on it just lights up the LEDs in order. It turns out we didn't tell them this, but the sample program we had on there, another thing I learned was you want a sample program on there that tests every feature of your board. So, and when you press the button down, it actually makes all 4 light up at once. That way, if I'm going around before the class is set up, I can very quickly make sure that no cold solder joints have come up. So now I know I've got a good board at every spot. So they plug it in, they see the lights going, is everybody there? So then we'd say, okay, our first program, and we'd have them, everything is very simple. It's, go click on this button. So go load, file, sketchbook, simplest. And you'll see a bunch of, lights blinking on here, and then the first LED is going to start blinking. And you say, okay, is everybody there? Everybody's got, I'm there. So then we would go through and we would explain, and we'd explain every line of it. We have constant pen LED equals 0. And I'd say we have 4 LEDs. Programmers start counting with 0. Why? Because we don't want to waste a number. So we start with 0. So we have LED 0, 1, 2. What?
It's as good a reason
as why not, right? It replaces pen LED with 0 everywhere in our program. I said, why would we do this? Well, let's change the constant to 1. And now everybody go press the arrow over there. They press the arrow over there, and all of a sudden, which light is blinking changes. Go ahead and change it back so the first LED is blinking again. Then we talk about, okay, setup gets called once at the beginning of the program. It's got pin mode. We'd say output and input. Output means you're speaking out from the microcontroller. Input means you're coming in from the microcontroller. Loop is then called. Every time after loop finishes, it's called again, and again, and again, and again, until you remove power. So then we talk about digital write. High turns on an LED, low turns it off. We made a mistake in our Wizarding 102 class. We accidentally, not thinking about it, hooked the LEDs up backwards like we did in the 101 class. You wouldn't believe how much more confusing it was for the kids that low made it off and high made it on. From an engineering perspective, you think it doesn't matter. You just need to know whether it's active high or active low. From a teaching perspective, I will never again do it where low turns it off.
So you want always. So what turns it on? High. What do you want to have turning on? High or low?
I would like high to be turning it on from a teaching perspective.
Right.
Yes, from an engineering perspective, it doesn't matter. Right? You just pick one, you move on with life. And then we talked about delay being the number of milliseconds. I didn't think I needed to do this, but it turns out not everybody works in units like milliseconds. So telling them things, even if you expect everybody will know, helps. So telling them a millisecond is 1,000th of a second, so 500 is 501,000th or half of a second, if we change the number to 100, will it blink faster or slower? And you'll get about half the class telling you faster and half the class telling you slower. And you'll say, well, instead of arguing about it, try it. So they'll go try it. Then, before we gave them the first challenge, we went ahead and gave them some gotchas. And we said, the program's not working. Here's some common problems. Case matters. Case matters is probably the largest problem you have. And the one thing I would change about using the Arduino software is people typically make case mistakes. Forgetting a semicolon at the end of the line, parentheses in the wrong place. I have up there using single equals when you mean double equals. I shouldn't have that up there. What we did is we got rid of after we went through the class the first time, we got rid of everywhere in the examples that you needed to have a doubles equals. It was just too confusing. It was too likely to make mistakes. And what you want here is you want fast success. You want people to come away with, oh my gosh, I can do this. Now some of the kids will come away going, that was interesting, but it's not really what I want to do. But you want every child to leave going, I can do this. This isn't beyond me. This isn't just for people that are super smart. Because it's not, right? So the first challenge they get, and of course we kind of start out with the whole shtick, where we start with challenge number 0, because we don't want to waste a number. So we tell them, change the program so it blinks on for 1 second, 1,000 milliseconds, and off for half a second, 500 milliseconds. When you have it, raise your hand for us to come look, and after you've shown it to us, you can make other patterns. We say, if you're stuck, raise your hand for help, go. This makes a great way to do every single one of the lessons, is they're all the same, which is, after you've shown it to us, go make other patterns. Because some of the student pairs will be off to the races, and others will have every possible problem that you can imagine and could never have imagined coming up. So this way, you've given people something to do, right? They're going and making these cool patterns. So then we go on to 2 lights. And we talk about, okay, there are 2 lights, 0 and 1, and here's the pattern. Comes into their board. The next challenge is change it to all 4 lights. You see, these are all little bitty steps. They're all kind of copy and paste. I tell the students, Control C and Control V. Control C is for copying and Control V is for pasting. And that way you can remember that that's how you put it back in there. And you want them to do that because they'll be a whole lot faster when they're copying and pasting, or copying and pasting as we call it. Then we kind of go into, there's a push button. One of the things that they changed in the Arduino software between 0.9 something, is they added this input underscore pull up. I love the person that did that. Because before, when you were explaining, oh, you're doing a digital write to here, even though you're not actually writing anything because you're trying to tell us that, we would just say, put this line in and it's magic. You don't really want to do that. Explaining everything. So, I say that there's an internal pull-up resistor here. I don't explain what a pull-up resistor is. Just kind of, that's why it's a pull-up. And sometimes I'll have some student ask me, what's a pull-up resistor? And I'll go over and kind of explain it to them. Normally it's somebody that's done something with electronics. So, digital read returns low if the button's pressed, high if it isn't, and we can make decisions based off of this. So instead of going through and explaining every line of this, we have them go put this on their board. We say, try pushing the button. What's it doing? Oh, well when I push the button, the light comes on. You're right. If it's low, it's turning on the light. When I let go of the button, it's turning off. You're right. You're exactly right. It's turning off. You got it. Now what's happening is, instead of trying to introduce if with math, we're introducing if in a very physical, very tangible way. They're seeing, when I do this, I get a light turned on. When I press this, I'm reading an input into the processor. At this point, I normally take one of the students' boards and I unplug it like this. And I have a battery. It's just a normal lithium battery, 3.7 volts. And I attach it to the ground and voltage pins on the back of this board. And the board just works. And I said, everything you've made is on this board. The computer is just used to send the program down to it. Because before that, the kids don't really believe me that everything's on here. They think surely the computer is doing something, but it's not. Everything you've just done is now in something this size. So, now the next challenge, we have them blink the LED 0 if the push button is pressed, and LED 1 if it isn't. Then we kind of go on to for statements. So, one of the neat things about the for statement is, we're just going to make it blink that number of times. Because they can count it. It's easy. We start out with a 4. And I went back and forth about whether to use an increment operator here. It turns out everything is new. They're going to see an increment operator a lot. So just go ahead and do it and say what it is. I've not had anybody concerned about, oh no, what's this plus plus? Everything's new, so it's just one more thing that's new, and it's okay. That doesn't mean that I would do fancy things with an XOR operator and try to explain that. But, so we have them change 4 to 8. Then we have them make a program that blinks LED 0 4 times in a row, and then LED 1 4 times in a row, and then repeat over again. And so you see this, each one of these kind of builds on. So, what do we learn? First one, this works great. Everything is so easy, and they can see it, and time goes by so fast. They are stunned when 2 hours are up. When we come back from, I'm talking about battery. If we have a couple things we did learn. If we have different volunteers throughout the day, get the ones that are programmers to help you at the end of the day. Because as everything builds on itself, the problems people can get into get a lot more difficult at the end of the day. It turns out anybody can help at the beginning of the day. Because they're learning right along with the students. They may not think they're going to be learning, but with this, anyone can learn to do it. And so, I had, everybody that came the first time had no problems helping. Some of the people that came at the end of the day that had not seen the whole thing, struggled. So, the other thing we learned is the first year we were so excited, we sent these boards home with the kids. And so every student took home with them, a board, a programmer, and a piece of paper that told them where to get all the software and how to install it on their home computer. We went and did a survey, and we found out that almost all of them were in a drawer somewhere, close to a year later. That was a waste. And so we said, we're just not going to do that anymore. What we do now is, if a week after the class is over, because right after it, all these parents are asking me, how can I get one of these? How can I have it at home? My daughter's so excited about this. My son's so excited about this. And what we do now is a week later, we send out a note to all the parents whose children were in the class, and we say, if your child is interested in having this at home, have them write up for us in one paragraph of what they're going to do with it. I don't care what the paragraph says. If the student cares enough to write one paragraph about what they're going to do with it at home, we'll give them one. Right? But now instead of trying to give out 25 of these, I maybe have 1 or 2. So then we had a problem. We had all these kids that were really excited from the past year, and they're coming back. So we had already split up into different age groups. We had the very youngest one did some Lego challenges, the middle age did some snap circuits, and then I had like the 12 and up. So it had been a year, and we really couldn't expect people to remember very much. So we know we need to reintroduce things, but we need to move on quickly. So we made a Wizarding 102 board, which this has on it a little OLED. I'm not sure how to do this very well. Maybe that's why they have a different color back here. That's exactly why they did that. So it has 2 push buttons on it. It has 4 LEDs, so we could, in theory, we could use the same ones as before, except for we hooked it up so they were active low instead of active high, so none of the permits work. Whoops. It has a piezo buzzer, which luckily I was smart enough to realize if you put a piezo buzzer on there, you do not introduce it until you are in your last 5 minutes of class. Or you will go crazy. And then, so we have 2 push buttons, the piezo buzzer, the 4 LEDs, a little OLED screen, and we broke out almost all these GPIOs, even though we had no idea what we were going to do with it. Because once you make a board past a certain size, we made these boards at Seed Studio instead of OSH Park. And so it was the same price once we got to a certain size. So the cost for these boards were $11 per board, and that was in quantity 20, which is amazing to me. It's kind of like, wait a minute, you've got a display, 2 push buttons, 4 LEDs and a buzzer, and you're $11. So
Was that the price of the assembled board? Did C Studio do the assembly for
we
you?
did not have Seed Studio do the assembly. What I did is I sent out an email saying, anybody here that knows how to use a soldering iron and isn't scared of surface mount parts, please meet us at the lab at 6 o'clock on Wednesday night, and we're going to have a soldering party.
Pizza provided.
Where did you get the 328?
I've got a full bomb here. Let's see.
So all of these things were hand soldered?
Yes.
These
These weren't. These we did, and one of the guys I work with has a reflow oven that he made out of a toaster oven.
Okay.
And we hand soldered that. He did the pin controllers and everything out of it. So we did these on the reflow oven because we were trying to do 50 of them. We were only trying to do 20 of these boards, and it was just, the other sad part is when I did the first Introduction to Arduino class, there was this wonderful place in town that has since gone called Tech Shop that I was able to do amazing things like use their laser to cut out stencil mask out of Kapton. For this, since we were only doing 20 and I didn't have access to a laser anymore, we just did it by hand. And the way we did it is the people that were younger that had better eyesight than I have would do some of the soldering of the 328s, and some of us that were not nearly as talented would solder some of the bigger components. We set an assembly line over train. We did have a few, that's when it became really important to have a test on here that tested all the components, so you could make sure. So if I power this up.
So that $11 included the programmer as well, again?
No, the programmers we reused from before.
Okay.
So if you add in the extra $2.35 for programmer, it should up to $13.50.
Did they up your budget the second you ran out of gas?
Well, because we weren't going to give them to the kids to take home. So yeah, they're a lot less concerned about the budget if we can say it's going to be reused from year to year to year. But yeah, so the Atmega 328s just came from DigiKey. So we bought them. We bought them at butt 99 a piece. So.
So is that scrolling lines that just a sampling artifact?
It is. Yeah, it's fine if you look right here. It's just. So yeah, actually, I'll show this real quick just for. This is what
Probably have to push a button to test the buzzer.
In fact, I think I made it where you had to push both buttons. Right. I didn't want somebody to accidentally find it.
Right.
So this is kind of, you can kind of read that, I guess. This is what the bomb looked like to make all of them. So, the most expensive thing, as you would expect, is the display, but it was $3.33 a piece. I mean, the fact you can get some of these kind of prices is just like mind-blowing, right? So, $3.33 for that, $2 for the Atmega, and PCBs came out to a little over $2 a piece. So, yeah, that's. So here's a real quick example. We started out with with lights real quick, just because it would help them remember. Again, it was really painful to explain why the lights were backwards this year of what they were the year before. So I wouldn't do that again. But we talked about the display. And for our display, which is an OLED, we can turn on or off any pixel just like an LED. So we start out with these are just like LEDs. And so we talk about X goes from 0 to 127, y goes from 0 to 63 on the display. Then here we talk about how everything is actually in setup and our loop isn't doing anything. So we're just going to draw to the screen. So we would start out, and I went back and forth about this. I ended up using literally libraries on this one to make it simple. Part of me felt bad about doing that. One of the things I really like about the 101 is there's no magic. But looking at it, it's kind of like, okay, realistically, if you're going to use these parts, you're going to use a library. There's no shame in that. And going over how the SPY protocol works for the kids, I won't get through anything. So we're just not going to worry about that. We're just going to be, this is how you set it up and it works. So, you know, I did tell them, you know, the numbers after the display, that's just telling the chip what pins they're connected to. I didn't go into any more detail than that. We turned on a single pixel and we told the display to update. And I said, well, we could just use draw pixel over and over again, but that would get really old in a hurry. So let's make a function to draw a horizontal line. So a for statement allows us to do things multiple times. We give it a starting value, a condition to check, and something to do after each time through. And again, we remind them that plus plus means it equals that value plus 1. And so we go through drawing a horizontal line. Now, a mistake that I made is on this one, the challenges sometimes took a little too much. It had multiple steps. So I make a function draw a v-line that's exactly the same as drawing a vertical line. I should have given a little, the hint I gave here needed to be like in bold, which is a vertical line has the same x and the y should change. The problem was I should have made that just the challenge. Make a vertical line, when you've got it, raise your hand, and then the next challenge should have been make a rectangle. Trying to do it all at once, which now involved them making a new function that was drawing a vertical line, and then figuring out they needed to make 4 lines to make the rectangle. They should have been split up. So we'll change that before next year. I mean, and I told them to make sure your draw V-line works before you try to draw the entire rectangle. But at this point, they've had enough of the Kool-Aid.
That was hint 3. They were still
Exactly. There is no need to read all that. You told me to make a rectangle. I'm off to the races, right? You know, this trying things one step at a time, you know, that's for people that aren't good at this. I can do that, you know, no. You know, they're not naturally going to take things one step at a time. They're going to say, okay, I wrote the whole thing, and I ran it, and it doesn't work. So one of the things we learned was they need to be broken up. So then the progression included animation, making a stopwatch, making a countdown timer, and making a game timer, kind of like a chess clock. And finally, sound. Now, this was amazing. When we had them do, we had it just counting up, and it was counting up, and then when they pressed the button, we started over from 0. And they would do this, and they'd go, and you'd say, you just made a stopwatch. I did. That's exactly how a stopwatch works. You would do a countdown timer, and you would say, you just made the controls for a microwave. Well, sure, why not, right? What's different between turning on an LED at the end and counting down and turning off, turning off the actual microwave guts? And so that part was exciting. Having sound last was a good idea, because once we showed the sound, everything else was kind of gone at that point. So some questions. Some of mine. Will I ever do the version 2 of the book I've threatened? I don't know if I will or not. Should there be a Wizarding 103? It turns out that we know as the students get older, the idea of coming to spend a day at work with mom or dad becomes less exciting. The amount of schoolwork they're going to miss goes up. And so we tend to have a lot of attrition. So are there enough people that come back for the 103 to make it worth it? And if so, what do you put in it? So what are questions you have?
How do you think this would be different if you were using a Raspberry Pi and Python instead of using
Yeah.
Arduino or whatever else.
So I've thought about using a Raspberry Pi because the advantage of that, if you did a class, is everybody could just have a Raspberry Pi and a display and a keyboard, and you could keep the cost down that way. The concern I have is the farther you're getting away from the hardware, the more levels of abstraction you're putting in, the harder it is to make the connection that what you're doing has this impact. So I don't know. I bought a Raspberry Pi with the idea of seeing if I could get that to work. I haven't come up with something I'm happy with yet, but yeah.
So are you doing the 101 and the 103?
Yeah, what I did is the 101 class, somebody that helped me the year before, he's now teaching it in a different room.
So both the same day?
Both the same day, same time. Yeah. We did a 101 class for Wake Robotics, where we opened it up for anybody that was interested. And the number of parents that came that had never done this before, that were amazed, thinking, wait a minute, I can do this. You know, there's something that's kind of fun about watching, you know, there were a pair of ladies, both in probably, I guess their 40s, they were just giggling hysterically over the fact that they could make these different patterns go racing back and forth, right? That's cool, right? They didn't realize they could do stuff like this. A set of 25 laptops. And so I found out that that's really difficult to do, and I may or may not be able to pull it off very much. So, but having all the laptops the same makes this so much easier. Yeah.
So with the Raspberry Pi, you obviate the need for that.
That's right.
On the other hand, you have to come up with 50 displays and keyboards and so on. But as a quick FYI, a Raspberry Pi makes an excellent Arduino development environment. It runs the IDE exactly the same as on Windows. You can do the whole thing. You can do your one-on-one course using the RTI and your hardware.
I wonder what the cheapest is you could get a display, because that would be your most expensive part, right?
$30 for
I got,
Craigslist
at my
if you
class,
want.
I went to a trade-it, and I got nice monitors, they were the old 4x3s, which is what I wanted. I didn't want them, and I got them for $10 a piece.
HDMI.
Well, none of them had HDMI. A couple of them had DVI, but I have the
So you do the HDMI to
cable.
VGA converter.
Yeah, so, I mean, these, $10 for a whole bunch of monitors a piece.
The converters.
So it was, the converter's $32. The kids don't get that.
There's a
They're,
place
you
in
know,
Durham.
what site you get them from?
Pawn shop.
Trade it, it's a,
Pawn shop.
yeah, and he just gets tons of them, because there are people who have got, you know, great big huge ones, and are turning into square ones, and they work better for writing programs than the big wide ones. So I give them cheap.
Craigslist can be a good source, but not for 50. There's a place in Durham, down near the tobacco district, that's recycling computers, and
I
they're
contacted a couple of companies in Wilson
and they're
who are
making
upgrading.
equipment like that available for a song.
Do you know anybody who works at SAS?
I do know some people that work at SAS.
In the building R down in the basement, there's a stock room. And last time I was in there, they were selling 1024 by 1280 monitors that had been displaced by the newer generation. $25 a week. Might not still be there, but it's worth a shot.
Yeah.
The public or all the employees?
Well, if it's
That's for the public or only the employees?
I don't think there was any real restriction on it. I was a contractor there, and
The base work, I don't work there now, in times past, they were only the employees do that. Then they may change that, so I was wondering.
you have an employee behind like I've never seen. I don't think there's any, they're gonna take you to court for $25. Well, who knows, maybe they will.
Yeah, I mean, I really think that you know, you could probably use a board. You probably use a board like this, maybe not all the connectors broken out, and you could do most of what I did in this full class. And the reason why I didn't do the programming with it is I didn't want, again, this is back a few years, I didn't want, a lot of the students did not have laptops or did not have access to laptops. One of the things that's really important to me is I want students to be able to have access to this and try to keep the cost as low as possible so that it's not a limiting factor. You know, one of the nice part about doing my work is they provide all of the stuff, and the infrastructure is great. The downside of doing it is most of the people at my work, if they decide their kid is interested in the Arduino, can go buy a Arduino SparkFun Inventors Kit and no problem work with their kids through it, right? But
As laptops become more available, could you build a bootable thumb drive? I'm not sure how.
that's a good idea. Make like a live CD, but that's actually, it boots off that, so that's your
Right.
image.
Yeah, so here's your image. Everybody who can, bring your own laptop, plug this in, boot.
Yeah, because then you would eliminate some of the, everybody has something different. That's a really good idea.
The only problem might be that if their drivers, hardware drivers, like their serial port drivers, are different.
Right, yeah, I haven't done any of this, so I don't know how particular a boot would be for any particular laptop, so that's definitely.
It has to be set up in BIOS, or in some cases, you can hit the F12 key on a lot of machines as you're booting, and it'll bring up a menu of devices to boot from.
Right.
And if you happen to have that plugged in, you can choose it.
Right.
Yeah.
By the way, regarding the monitors and stuff, they're a little harder to find than they were a while ago, but if anyone's ever seen the Motorola Atrix laptop dock, which horribly failed, but I have one. I bought it was originally like $500 or $600. I bought it for $50. It has HDMI, USB output for power, and USB input. And I use it constantly for my Raspberry Pi, my BeagleBone, all that, where you just plug it all up. I don't have to have any, external power source or whatever. It'll power the Pi for a couple of days. And then you've got a full monitor and stuff. So, probably not great for a class, but if someone's looking for one, you can find them now for $50 or $60 on eBay.
Say the name of that one.
So Motorola Atrix, ATRIX, laptop. It takes a little bit of hacking at it, and you kind of need to adapt. It's a micro HDMI, so you need to adapt from the micro HDMI to a standard HDMI.
They made lap docks for a couple of their other phones too. I have one that I think was from a Bionic or something maybe.
Yeah, I've seen others. That's the one I have. I would love to try a couple.
Yeah, I mean, something else, make sure that people here aren't familiar, a way to get, like, the way we got the OLED so cheap is we bought them from AliExpress. So you can, so here's this is my experience, your mileage may vary. Getting stuff from AliExpress, so it's going to come from China. You are going to have, depending on what you're getting, you want to make sure you get things that you know whether they're legit or not and can tell very quickly. So that's one of the reasons, even though we could get the 328s cheaper that way, we elected not to do that. We elected just to get them from DigiKey, because that way you know the 328 is a part, especially when they were when there was basically a run on them and they were under allocation. There were a lot of people that were making fake 328s, and they would die in sometimes completely unpredictable ways. I mean, sometimes they were easy because they don't start up, but then we decided that the risk was just not worth it. That we just go ahead and buy the part from DigiKey. We decided a display was something you could pretty reasonably know if it worked or not. So. And that's not casting any dispersions on AliExpress. You want to be more careful.
Why did you go with the outboard resonator versus just using the 8 meg internal clock?
It'd be fast enough to drive it over.
Stable enough? You mean stable enough? I mean,
Yeah, I mean,
you could program the 328 to run with an internal 8 megahertz clock source. You don't need a outboard resonator.
yes. Yeah, I mean that's what we did on the AT Tiny. You know, the AT Tiny. This board here has nothing on it except for an RPAC, 4 LEDs, the AT Tiny, and push button. So that's all that's on this one. It's just using an internal resonator.
I just wondered if it was like really sloppy, the timing was sort of sloppy without the resonator.
Other than the code that was in the project, you don't teach the kids, or didn't teach the kids, any additional coding.
For the Wizarding 101 and 102, it's all, here it is, here's a challenge that involves basically some minor modification to understand what it's doing. We're not doing a go make your own project with it. Is that your question?
Yeah, so when I do it, the kids are learning Python before they get to the project. Then they have code, and I intentionally leave part of the code out that is in the stuff that they learn. So they have to add it in there. You didn't do any of that kind of thing.
No, this was much more of a, you're modifying it, like for example, it would start with blinking the light 4 times. Change it so it now blinks 8. So it's not a get all of the syntax right and everything else. It's a understand that this little piece is what does that.
It's also start to finish in less than 3 hours.
That's right. Yeah, this
Mine's
is,
a week, so.
yeah.
Yeah.
Yeah, no, I mean, this is not a, I am not billing this as you leave and you are a programmer. This is, kind of an introduction. Yeah.
Could you show us the BOM item or description of the program? The $2.35.
I think that's Bob's one.
It's bought from AliExpress.
AliExpress.
Yeah, I can find a link and send it.
I got a couple of those.
Yeah, I mean, there's some strange things because of that. So, like,
So it's more than an FTDI.
Yes. So the strange thing about it, that we wouldn't have done it this way, but we couldn't. Oops.
It's good.
See how there's a, for some strange reason I don't understand, this is a 10-pin connector with cable. Instead of 6. Well, we would have done it as 6. But it turns out that we could not find a way to get anywhere close to the price of this program. And so we said, nah, 10 pins is fine. One thing that's kind of cool that's done on here is, if you see here the edge of that is soldered on. So we basically have the pads on top and on bottom of the PCB, and then we solder it sticking on the side instead of a more traditional sticking in or sticking down like that. Yeah.
I have this exact one, and I was also able to get an adapter from 10 to 6.
Yeah, we saw.
But the reason for the 10 is because that's JTAG compliant. If you look at a JTAG,
Yeah.
if you look at the JTAG pinout, that's what that is.
Okay. Yeah, we looked at doing like 10 to 6, and the problem is the 10 to 6 adapter was going to be more than the programmer. Again, we're trying to.
And so why wouldn't the edge of the OSH part board, that connector be a female who was plugged right into that? Why did you need the ribbon cable to?
The ribbon cable came with the programmer.
Right.
So the ribbon cable came with the programmer and allowed us to make it so that the students could hold this
Not shove it into the USB board.
and not shove it in. Gotcha. But yeah, if it hadn't come with the cable, we might not have done that. But I mean, yeah, I was amazed when we first. I'm like, surely these are not going to work. One other problem that we had, it's a minor problem. This has a jumper on it between 3, 3, and 5. We made these original boards. These will run either way. But when we went to the one with the OLED, we just went ahead and made them 3.3 volt boards. So as a result, and something I would do differently, we only modified enough of the programmers to remove the jumpers, the ones we needed 3.3. This is dangerous. You should not do this. Once you let the smoke out of a part, it doesn't work anymore.
How many did you let the smoke out of?
We haven't yet, but that's because I've got two very separate boxes, and all the ones that are, all the ones that go to Wizarding 102 are permanently attached to this, and they're never in the same classroom, and we store them in different places. But still, when I set it up, I check every single one of them, because otherwise I know that, you know, we're gonna get one
So forgive
swapped.
me, but how long would it take you to modify them all to 3.3?
Not very. We ought to just do it. 'Cause I mean, it's one jumper, so it's.
You'll sleep better.
Yeah. So, yeah, the problem is I always think about that I should do it as we're setting it up right before all the students are going to show up, and they're downstairs with the HR person right now, because I really meant to come do this last night, but somehow I didn't get around to it. And oh my gosh, I'm going to be here in just a few minutes, and I'm getting each of these working, and I promise after this is done, I'm going to, and then when it's done, I'm going to put them in boxes. And
Bring more to Wicker by sometime.
Yeah.
I'll do it.
Other questions? Isn't this fun? Isn't that exciting that you can get, I mean, one of the cool parts is I have not yet had a student that couldn't do this.
How
The
young?
only, what?
How young is the youngest?
So when I did the class as part of homeschool co-op, I did 10 and up. When I'm doing the one at Qualcomm, we do 12 and up. I think I could do younger than 12, but you start to run into more you start to run into a wider range at the younger years as far as who's ready for it and who's not. When we did it at Wake Robotics, I think we had some, there were 9 that were there, and they did just fine. So, but a lot of those that were 9 there had a parent with them that would be like, now's not the time to interrupt the entire class to talk about what you did last week, you know. But
They're self-selected for more attention as well at Wicker Robotics,
Yes.
I think.
so. It happens with grown-ups too. I get it. Yeah,
Random quick question. Am I right that that programmer is just a 328 running VOSD?
you're exactly right.
Looks like it.
AliExpress has a 7-inch TFT LCD display with HDMI for $27.
What?
Wow.
Can you
Oh,
send that
that's
to me?
The same AliExpress.
The same Chinese vendor.
Yeah. Wow. Yeah, because you do that and you go, okay. I don't know what the cheapest keyboard mouse combination you can get is, but you can probably pick those up pretty close to dirt cheap.
Logitech makes one you can get for like $15. I think if you look around, it's actually wireless, but it has a built-in trackpad too. I use that all the time for my Raspberry Pi, just as one unit.
State surplus is loaded with it too.
Yeah. So, yeah, I mean, if you did that, you could have a full development environment set up for people. You could say, okay, that's going to be a $50 cost of the class. I guess we're over $50. Where are we at now? 65. You said 35 for the Raspberry Pi, 27 for the monitor, 12 for the keyboard. You start adding up, right? So $75 for. That's crazy, right? We're talking about that being expensive. $75 for basically a computer. Yeah, one thing so when I did it the first time, I also did it without me having a computer either, because I thought it would be better if I had a whiteboard and that I wouldn't be tempted to put too many things in slides. It's better to just plan that you only get to talk for 5 minutes at a time, and then have people work. That just works out a lot better. Because when we had the hands-on time being them doing the wiring, I would have to go around and flash every board with the known good. What I would do is they would make the wiring and mechanical parts in the class. I would flash it with known good. Then they could go home and make sure the known good still worked. And then they could upload their programs to it. So that way it decoupled it some. But it's much better to have people working in the classroom. Thank you.
Thank you.